So welcome to polygons. Today we're going to look at some vocabulary, and then we're also going to look at rules for finding the interior and exterior angles and the sum of those angles for different types of polygons. The notes are broken up into two parts, right? There's going to be two separate videos. The first part is kind of in polygons and quadrilaterals in general, and then the second video will talk about those interior and exterior angle theorems. All right, so let's get started. Polygon. A polygon is a plane, P-L-A-N-E figure, meaning it's flat, made up of at least 3 or more straight sides. All right, so the smallest polygon is a triangle. It's got to have at least 3 sides. And they all have to be straight, meaning you're not going to have any curved sides. So when we look at these 3 figures, the first one, all right, it's flat, straight sides, and we've got 1, 2, 3, 4, 5, 6. All right, so this is a polygon, meets all the criteria. The middle one is not, all right, because of the curved sides. All right, so this is not a polygon, because of the curved sides. All right, or you could tell me because the sides are not straight. The third figure, all right, it's flat, it's got more than 3 sides, but all the sides are indeed straight. So this also is a polygon. Diagonals. A diagonal is simply a straight line that connects non-consecutive vertices of a polygon. All right, so let's talk about that word non-consecutive. If I start here at this vertex, the vertex immediately to its right, or I should say going that would be clockwise, or the vertex going counterclockwise, those are consecutive. So if you connect to a non-consecutive corner, you've created a diagonal. Okay. The middle figure, all right, pick a corner of the vertex. If you go clockwise, that's consecutive. Counterclockwise is consecutive. So the only way to draw a diagonal would be to go to that one, which would be the only non-consecutive. In a triangle, if I go clockwise, I'm here. Counterclockwise, I'm here. There's no place, or I guess there's no non-consecutive vertices, so there are no diagonals in a triangle. Right? But 4 sides or more, you will always be able to draw diagonals. Convex versus concave. All right. When you lengthen the sides of a polygon and that extension does not pass through the interior of the shape, it's considered to be convex. So this first figure is convex. If I were to extend all these sides, notice these dotted lines never go through the interior of the picture. All right, all the corners looked pushed out, so to speak. So this one is convex. If the extensions do pass through the interior of the shape, then it's concave. All right, so right here, when I extend this long side right here, I'm going to pass through the interior. If I were to extend these little pieces right here, it's going through the interior. So these vertices look like they're kind of sunken in. That is concave. Okay. The word regular. You're going to see that word, especially when we get to the interior and the exterior theorems. All right. A regular polygon is when a polygon is both equilateral and equiangular. So looking at this first figure, All right, the opposite sides are marked congruent, but not all four. So it's not equilateral, but all the angles are marked as right angles, which means this would only be equiangular. All right, it's only equiangular. This middle, that kind of looks like a diamond, there's no markings on the angles at all, so we don't know that they are equal, but all four sides are. So this is only equilateral because all the sides are marked the same. If all the sides and all the angles are marked congruent, then this is considered to be regular, right? For a quadrilateral, a four-sided figure, all right, your regular quadrilateral is a square. Down here, this shape has 1, 2, 3, 4, 5, 6, 7, 8. So that's an octagon, and we'll review all those names in a second. But notice how it's marked. It's all 8 sides are marked with the same tick mark, so they're equilateral, and all the angles are marked with 1 arc measure, so they're all equiangular. So this also is regular. Okay, but it has to be both. Now, on the next page are all the names of the different polygons that you should know. All right, 3-sided figures are triangles. 4-sided figures are quadrilaterals. 5 is pentagon. 6 is hexagon. 7, you may call it either a heptagon or a septagon. All right, it has 2 names. 8-sided figures are octagons. 9 are called nonagons. 10 is decagon. And so for 11, you've got a undecagon, kind of like one more than 10. And 12 is a dodecagon, right? Think of do or dos, whether it's French or Spanish, means 2, and then the decagon behind it. So 2 more than 10. Anything above a dodecagon, we just put the number with the gon behind it. So we'd have a 13 gon, a 20 gon, and so on and so on. Okay. You should be familiar with these names. Now, when you are naming or labeling a polygon, this is very, very important. You start at any vertice, but then you must continue either clockwise or counterclockwise without skipping any vertices. We're not going to zigzag. So in this first, all right, looking at how it's labeled, when we want to name it 3 different ways, I can start anywhere. All right, let's start at A. So if I go clockwise, then this would be figure A, B, C, D, E, F. If I went counterclockwise, this would be shape A, F, E, D, C, B. But I can really start anywhere. I could start at C if I wanted to, and again, go either clockwise or counterclockwise. So if I go clockwise, a third name would be C, D, E, F, A, B. And there are many, many, many more. So when you are given the name of a figure and you're asked to sketch or draw it, all right, now notice this is a pentagon. So we're going to draw a 5-sided figure. And the name is LMNOP. So I can put L anywhere. And then I just need to go in the order of the letters, either clockwise or counterclockwise. All right, so I've got L, M, N, O, P. We're not going to zigzag back and forth and just randomly put the letters. Okay. The interior angles of just a quadrilateral. All right, and of course a quadrilateral is 4 sides. The sum of the measures of your interior angles of a quadrilateral is always 360 degrees. All right, triangles was 180. That was 3 sides. Quadrilaterals is 360. That's 4 sides. And we will learn in a second how to figure out what would be the sum of 5-sided or 6 sides or 7 sides and so on. All right, but you will notice if we wrote them out and looked at the pattern that each sum always increases by 180 every time we add a side. All right, but just doing quadrilaterals for right now. All right, when I look at this figure and notice it's a quadrilateral, then I can set up an equation that says x plus 143 plus 48 plus 58. Oops, look what I did. Don't do what I just did. Is going to equal 360. I wrote 180. Don't want you doing that. All right, now my calculator is not handy, so let's see how I am with some mental math here. So we've got 191, 58. So x plus 249 will equal 360. All right, hopefully I did that right. And then we subtract the 249. And x is going to equal 111 degrees. Okay. Over here, this one has some little algebra because we've got some algebraic expressions. So we've got 5x plus 7x plus 70 plus 50 will equal 360. So 12x is total plus 120. Subtract the 120. So 12x equals 240, and then divide by 12. So x will be 20. All right. That takes care of the first worksheet and the first video. So go ahead and practice that first worksheet. Come see me if you have any help. And when you're ready, you can watch the second video and the interior and exterior rules.